ground stations transmit with radio to a geostationary satellite, and the data is then distributed to the satellite network. Satellite-to-satellite communication is quite easy. That can be done by laser, for example, because you have a line of sight in all the cases, so you can communicate really fast by laser. Getting up there from the planet to satellite through the atmosphere is not that easy, but it's also not that hard. But you need quite of an infrastructure, so that's why not everybody can do it at the moment. I know that there are experiments with LEO satellites, with low Earth orbit satellites, but that's a bit harder, or they're a bit harder to catch. But they can be catched by amateur radio, for example. So, we have the blockchain, the blocks are sent, or the block headers are sent to one satellite and distributed in the satellite network. After that, there's a downlink and the data is transmitted back to the planet. It can be received and decoded with, and this is, for this case, this is important, it can be decoded with broadly available and affordable hardware. So that means someone that can't afford an ISP to pay an ISP every month, some US dollars, can afford satellite equipment, which costs, in this case, less than $100 US if you get the right point to buy it, I would say. So it's broadly available and it's affordable, and you have a one-time payment instead of monthly costs. Then this network enables then a cheap, sensor-resistant. At the moment it is not, obviously it can be censored by blockchain, which operate the only upstreams. So the upstreams have to be diversified for it to be really sensor-resistant. But it is kind of, because when you run a node, when you have the possibility, and there the redundancy comes in. When you have the possibility to run a node on the internet and connect it to a satellite, then you have normally 8 channels from the internet where you are connected to 8 nodes, where you cross-check the information you get, and you have the satellite connection again. And it's private, of course, because no one can tell where radio waves are received, so they are just spread over the planet. At the moment, for this network, everything but Antarctica is covered. Sorry, Antarctica is somewhere. It's bad luck. But the rest of the planet is covered well at the moment, and so anyone can receive without anybody noticing that he receives blocks from a blockchain, from any blockchain. But in our theory, let's build that, and that's what I did. You can see the things you need to do that. There's a satellite dish. That's a normal TV satellite dish you have there, with a normal TV LNB, which is the antenna you see there. So this dish is just to concentrate the radio waves on this antenna, and then it goes to the computer. It's then decoded with an SDR, software-defined radio, which is a simple USB stick. Then you need a laptop where you have the software running. Blockstream built a program on top of Blue Radio here to decode the data and to help you with the alignment of the dish, which isn't that easy. You can see on the picture it is dark already. It was a Saturday and I started late afternoon, and it was getting dark until I finally we'll look closer to that afterwards, I think. Yeah, here we do. So, here you can see the alignment software that helps you to find the signal. You can see the signal in the spectrogram there. You can see that it's shifted, and yeah, that's too much technical stuff, I would say. Here even more, you can see the signal-noise ratio, which has to be good. So you have to be over a certain threshold to be able to decode the data. On top, you can see the logs from my Bitcoin client, which is now receiving block headers from the satellite. In the middle, there we are waiting for other data. We'll come to that in a second. And yeah, I've been talking about the bottom part. The middle thing is an interesting thing, because in the current Blockstream Satellite network, there's bandwidth allocated for any messages. So you can now send whatever you want over that network. So that means if you have a blockchain that you wish to have a redundant chain for, you can use also the blockchain, the Blockstream Satellite network. And guess what? We're going to do that today. Although I have bad, or despite my bad reputation when it comes to demos, I tested this 2 times in here an hour before. So I'm rather positive that this one should work. What's our setup? We start on the right side of the screen. There we are with our Meetup laptop. We're going to send data and some Satoshi Bitcoins to the Blockstream servers over the internet. So we first send data, and Blockstream sends us then an offer how many Satoshis per byte we have to pay for that. If there are lots of people sending messages, then we have to pay a lot to be high in the queue. If we can afford to wait a bit, then we can be prioritized later with a lower price. What I saw there was this afternoon was 1 other messages apart from my 3 test messages, so we should be good with that. The price should be rather low at the moment. They switched to the Lightning network, to the main Lightning network, so the payment is with Lightning Bitcoin. Then we are on the Blockstream server. The server decided that we're high in the, that we're number 1 in the queue, then we paid. We have instant confirmation, as you know, in the Lightning network. So the message gets sent instantly to Telstar 11N. That's satellite Europe can see. It's down there, round about. Almost 36,000 kilometers away from the planet. It gets sent up there, and from there it's sent down again and to my rooftop, and then decoded by my computer, which the setup there at the office should look something like that at the moment. That was recorded this afternoon. You can see here the signal noise ratio coming in and the signal nicely coming in. There are some cranes in the neighborhood at the moment, I guess, because the satellite is rather low. They are a bit of a pain, but it always worked so far. So let's hope this looks now like this. Down again. And then, as soon as the message is received, it will be sent to a Dropbox file, where we can see it, and we'll look at the Dropbox file again at our laptop right here. In the end, this means, or some of you might say that this is a rather sophisticated way to transfer a file from here to here. It's just transferred to another folder, basically. But, as you know now, it goes over the internet to the satellite, back to the planet, and everyone will see that, and it will come back to my Dropbox folder. So, and when I say everyone, it's assumed that at the moment around 60 people are going to see this probably, so there are maybe around 60 people that have the equipment set up. It's a small project, but it's a really interesting one. So, I went to the Blockstream homepage. They have an API, and they set up a web page for that. That looks nice, so that's why I'm going to do that. I will not use any terminals or something like that. That might look scary. Let's see. Then we go to transmissions here. They said that they switch now to Lightning main net. Then we we are going to broadcast the transmission. Step 1, we have to choose a file. I have this one. Can you read that from there? It says Blockchain Meetup Liechtenstein Greece Planet, live demonstration, and so on. 243 bytes, as you can see there. And in the meantime, in the Dropbox folder, there's just a few minutes ago there was a file arriving, Blockstream News. Someone started to broadcast news over their network. You can see that it's like that. Apart from that, there are my messages from this afternoon. And let's choose the file now. It's a site. Then the file is not yet uploaded, so it says now 50 millisatoshis per byte is the current bit. We reassure that that's the top one, so that means is it 12 or 13 satoshis? Yeah, 13 satoshis we have to pay for that, which is way less than a cent. It might be 0.07 cents or something like that. We submitted, the file is uploaded, that looks good. We got a transmission ID now, so our message is now allocated with an ID and with an authentication code in case we want to change something later. Changing would be deleting it from the queue or like putting it how do you say, like pushing it more up in the queue if you pay more. Then we're going to have Lightning invoice, and with that, some of you might remember that demonstration that didn't work, where we have the Lightning node here and try to do a payment. I'll do another one now, that hopefully works. I scan the QR code, and there we have 12 satoshis, as you can see. And as soon we are going to send them, you know, they are confirmed instantly, and then the message will be sent. Let's do that. It's paid. And if we look, yeah, did you see that? Just you can see that's our message that now has been spread all over the planet by radio waves. There's a small outlook. What are we going to do with that, apart from the advantages we have right now? There are dreams out there what can be done with something like that. Now they are trying to figure out the communication paths. How can we communicate to satellite? How can we transmit as much data as possible up there and back there? You know, we have for example, for Bitcoin, a 10 minutes limit where the whole block header should be transmitted until the next block comes, and so on. So, figuring out communication. Where could that lead? The satellite that is used right now is one that is existing. It's an old one, or it's a rather new one. This one they had, or the one we used to receive is a rather new one, but it's just some bandwidth they rented on that. The next part would be to store a blockchain itself on the satellite itself. So that means we have then redundant storage place, and we are not. There is no danger of some terrestrial things happening where everything is wiped out or so. Then we have backups in space. What does that mean? If we have backups in space that can communicate the blockchain, then we can also start maybe to mine in space. As you know, proof of work mining uses a lot of energy. Where's a lot of energy? Near the sun, there's a lot. So that could mean that mining might be moving closer to the sun. There's a latency problem, of course. As you know, or as you might know, the latency to send radio waves from the sun to here is around 8 minutes, which is dangerously close to a block time of 10 minutes. But that's just a problem as soon as the main mining activity is on the planet still. If we look into a future where the main mining activity might be close to the sun, then that's no problem anymore. And then after that, it's we have an interplanetary currency, of course. We have a ledger that can exist in space, which is not solved right now. This could be something, if we dare to dream, this could be something we started to work today. Questions, please, and I hope we have answers.
So many questions.
Don't spoil the historic moment.
Yeah, exactly. Who owns the satellites, and who is? I mean, now you're renting space on Telstar, or what's the plan for that?
Yeah. So at the moment, the satellite is owned by a Canadian space company, I think, and it does nothing. But it's more or less it's a mirror, basically, right? It does nothing. Yeah.
But if you had to store data on it, what would the plan be then? Like, will they sell you storage space?
Yeah, let's see how that turns out. That's still far away. I think Gavin Anderson was thinking about it first. If I remember correctly, he said let's store the blockchain in space. So there are many open questions to that. Where we are today is just figuring out how the communication can work.
And with regards to the communication, I think your biggest threat is, solar flares and stuff like that also, that are a huge risk to any satellite-based system. So you would need more the redundancy for that.
Yeah.
So.
That's a risk, of course, like in all radio communication. I think the people setting this up might argue that they say we see more danger in someone censoring the internet communication, and here we have at least just nature between us and the satellite.
Censored by nature.
Yeah.
I think that's it for the moment. Let's go to the next speaker. I hope you have realized that this was a historic moment. It was the first transaction like this in public, at least in Liechtenstein, in Vaduz, in Technopark. Yeah, no, it's quite historic. Thank you, Philipp. You always bring the most recent things to us. Thank you very much. We're very proud of you, and I hope you have the next thing already in the pocket.
You saw that it was part one.
Okay, so we're looking forward to the next big thing. Oh, sorry, I'm not spying into your...
Okay, thank you very much. So, actually this is not the next big thing, but it's a huge thing. We all need that. And I'm not trying to sell it to you right now, although I could. But what I want to explain is the reason why we produce these. And I want to hand these out to you, so you can just take a look at them. There's 2 devices that we have here today. Actually, we have 3 devices, and I'll explain later on what they are. So, but let me start with a bit of history. So the internet was created 50 years ago, 1969. Oh, I wasn't around then, and I wouldn't ask who's been around back then. But so the internet was designed, or was created, to actually prevent or make computers communicate with each other in the case of war. So that you could still have communication and send data and other things. And the main idea, or the main reason for that, was decentralization. So the internet, to make it resistant against wars, it was created decentralized. Now, over time, This decentralization has gone. It's actually very centralized. And I'm not only speaking about the Facebooks and the Googles and so on, I'm talking about the infrastructure itself. So we have internet service providers, and they're all connected through nodes into the internet. Frankfurt has the biggest node in the world, actually. That's where the internet access point is. All the internet service providers use that node to get connected to the internet. And these service providers, they are regulated. Countries like Turkey say what kind of information can be shown, China as well. So people cannot access the internet just as they want. They can only see what certain regulators or certain centralized authorities allow them to see. And this has evolved over time. Now, why am I explaining this? So, I think that we're going the same path right now. Blockchain is designed to be decentralized. But today, 90% of the decentralized applications, they need access to the blockchain through a node. And they run on Amazon Web Service, for example, or other services that are centralized owned. So at the end, we create a decentralized system with a bottleneck that is centralized, which is the access point to the blockchain. If you look at Ethereum, 90% of the applications that run on Ethereum use Infura, which is a service by consensus. And consensus itself runs these nodes on Amazon Web Service. So it's almost double centralization. You know, it's like Infura is centralized, it's owned by a company that may run out of money and just shut down by coincidence even, on a service that is owned by Amazon. They can actually just say, we'll close down these nodes. So why is node important? So there's two main things that secure a blockchain, just basic now. Okay, there's mining, when they create the blocks, and then there's the node that actually seals the block, that validates the block. So every node in the network checks that the information there is also available, is valid. They also share this information. So nodes connect to each other, and they keep a copy of the confirmed transactions. So this is really important to have. If we have just one node running, we're not redundant anymore, and somebody can change data or can influence the data in this node. So, but why do you think nobody's running a node anymore? Is anybody here running a node? 3, 4. That's good. It's very good. Well, 5 actually. Forgot to raise my hand. But is it hard to run a node?
No.
You should say yes. Okay. So for a lot of people that really have knowledge, it's not hard to run a node. But we want to be really decentralized. We want everyone to run a node. Okay, that's sort of the best scenario we can think. But to run a node, you need disk space. We heard before that the Bitcoin blockchain has, I think, 200 gigabyte of disk space you need. Ethereum is almost the same. They have like 170, 100. It depends on the client you're using and the implementation, but it's around 170 gigabyte. Then for Ethereum, you probably need, or you definitely need an SSD storage. So you need a disk that has very high frequency communication. And there's others that maybe like in the future there's other blockchains that might need other hardware specifications. We'll hear about Polkadot as the last speaker, and he will explain as well what kind of nodes they need. Several actually. So at the end, this is the disk space, the hardware itself, is something that prevents people from running nodes, because I was running a node in 2015 on my laptop, and an Ethereum node, and I wanted to participate in the token sale, started my laptop, and guess what? The node was not synchronized, so I had to wait like half an hour and the token sale was over. So another point is you have to be online 24/7. You have to be synchronized with your node to be able to access the blockchain. That's also a point that is hard, sometimes hard to manage. Okay, it's not impossible, but if you run it on the same device that you do your regular work with, it's high bandwidth, high disk space, and it has to be online 24/7. So it's much easier if you create a specific hardware that you just put in a shelf, you connect it once, and it runs forever, you don't even notice it. But today the reason to run a node is very idealistic. So I mean the people that here that run a node don't do this because they have any return of investment. It's not like mining. You know, you don't get a reward for that. It's just you believe in this, and you probably have other incentives like developing on it. You want to be creating something interactive with the blockchain, and you know that you're interacting with your access point to the blockchain. We want to change that, so because we really think that it's important for more people to run nodes. Right now, I think there's like 8,000 or 9,000 Bitcoin nodes and almost the same amount of Ethereum nodes. And this number is slowly decreasing. The reason we want, or the topics we want to change, so right now it's a tool for developers. Oh, it's good to read, okay, my computer is very small. So right now it's idealistic, but it's also great for developers. Because you can have many test nets on, that you can access. You can just build your own product and interact with the blockchain directly. In the near future, we want to have people, or we want to create solutions that we call smart mining. So that these are tools that you can earn crypto with. For example, your bandwidth, or your disk space, or just by running a node, making systems redundant. These are ideas or topics that already are being worked on, but none of them is really live or on a mainnet. A lot of these solutions are still in beta mode or on test nets. Then the other one is, the next topic we want to solve is sort of a decentralized cloud. So I'm sort of running, or I'm involved in other blockchain-based projects. Swarm City is one of them, and we need access to a node. Otherwise we cannot work. We also run a node on DigitalOcean because it's more convenient. And if I run Swarm City to my own node, it is one instance, it's one time available. If somebody, if my daughter just plugs, takes out the plug of the node and it's offline, then Swarm City will be unavailable. So it's much more convenient to have it on DigitalOcean because we don't have a decentralized cloud yet. But if I can have 10 people that run Swarm City as an instance on their node, and I have peer discovery and I have like certain tools that make it possible for people to access these nodes or access Swarm City through these nodes, I don't need DigitalOcean anymore. And we pay more than a few $100s every month for DigitalOcean to run several instances of the node. And I could distribute this to the community. So this is something we're also working on, to have 100% availability for applications, and the applications will pay the users to run the nodes. Again, this is not available yet because it's not been created. And then the last one is very ambitious, I have to say, but it's really have your bank at home. So have your access point, have your store of value in your home and under your control. It's something where you have to have HSMs involved, hardware security modules, to secure your private keys. And again, this is all these topics are not easy to solve, otherwise they would have been solved probably already. But we see progress in that, and we support that progress as well. And if you look at the markets that we would dip our toe in, if these things are getting accomplished, they're pretty big. So right now, the tool for developers is a niche market yet, but it will grow bigger over time. Then the tool to earn crypto could be quite big already, because the blockchain application market is supposed to be in $1 billion in a couple of years. The cloud storage market right now is huge, and it's growing as well. So if we can take a fraction of that, it would be nice too. And I'm not saying we as a company, but we as a community. And the bank at home topic to me is something that we really need to work on, because I think that it's really important to own your own assets and have access to it, and not use a Coinbase or other topics. Right now we have really happy customers, so we're really happy about that too. The people post about running the nodes, but again, these are idealists. You know, it's not the masses yet. Just so you understand, what kind of motivates these people. The products you have, I handed them out. So we have a few products. We have 3 products right now. They all are different in the hardware specifications, but they all have an SSD drive in it, so they can all run at least the Ethereum blockchain. The 2 devices I handed out here can run several blockchains. They can run the Bitcoin blockchain and the Ethereum blockchain at the same time. It's more a matter of the bandwidth than the disk space. They create their own Wi-Fi network, and you can connect through VPN through them. So you can also remotely connect to your node. And if you go to an Ethereum name service website and .eth website, which is already a decentralized web space, you can access that if you're in the Avado network. You can resolve these websites. If you try this on your phone right now, it's decentral.eth is one website. You will not receive anything. This is not visible to Google or to anyone. But if you run it on the network, if you run it on the Avado network, it resolves. You can access this website. It's a decentralized website. Now, my co-founder and I, we've been in the crypto space since 2014 or 2015. Myself, he was a bit earlier. And we really like to use the tools that blockchain gives us. So what we've done is we only accept cryptocurrencies as payment, and we only accept DAI right now. It's a stable currency. I don't know if you know DAI, but it's very helpful. It represents $1 US, and it's not pegged to the US dollar. It's a different system. It's very interesting if you look into that. We give out a non-fungible token, which is the guarantee. So if people buy the device, they receive one of these cards. It's called an Ether card. And that's how we distribute the non-fungible token. So you have a public address that is visible right now. And then you have the private key. It's almost like the Liechtenstein topic, where you have the private key is sealed under a field that you rub open. And once you have that, you own the NFT, and you can transfer it to any other wallet then. And if you have any problems with your device, then you can just simply show us a transaction from the account that you have the NFT, and we know that you own the device and that the guarantee is still valid. So it's very simple. In addition, what we will create, this is not yet in place, we will create a crypto-based support marketplace. That means we can add any other cryptocurrency to your card, to this account. And you can use this amount of money if you have a support request. So you put this token or this cryptocurrency into a marketplace with your request, and people that solve your request will receive the cryptocurrency. It's like Gitcoin or any other service where you have developers work on topics. It's the same for support marketplace. We really like this idea because it helps us scale the support part. So, because we're only 2 people and it's hard for us to maintain it, but our community is very active and very passionate, so they help each other anyways. We just want to reward them, and if there's more support requests, then there's also more money in the marketplace, so there will be more people probably answering. Yes, I said it before, it's my co-founder and I. We've been in this space before. We've been involved in quite a few projects already, and we feel this is a good solution, and we really want to keep blockchain decentralized. So run your own node is our motto. Thank you.
Yes, thank you very much. Enthusiasts here and pioneers, and you are one of them. Thank you very much. Questions? No one?
So just a quick question. So with your, let's call it currency you are putting into your DAI there on the net, you are becoming somehow a bank. A bank, a real bank.
You mean when we offer the bank at home solution, or at the end? No, because you own your private key, we don't hold your private key. It would be if we would manage your private key, then we probably would be a custodian. So at the end, it's really a system, and that's why it's not existing yet. There is no, you can add a ledger to it, a ledger nano, another hardware wallet, but it's very cumbersome because you then have to attach it, you have to click a button. We want to make this much more user-friendly at the end. It should be like a wallet in your phone, but it should be very, very secure. That's why HSMs need to be built into the system.
Okay, thank you very much. And further questions at the end, maybe. Yeah, John, I think it's your turn. Okay, this is John Orthwein of Melonport, and he will show us asset management platform on blockchain, I suppose.
Thank you very much. I don't have a presentation tonight. I'm just going to show you what the project that we've been working on. I'll first start by just explaining what it is that what we set out to do and what we created. Melonport was a 2-year project that set out to create an asset management infrastructure, or rather fund management infrastructure that's completely decentralized. So every aspect of it is decentralized and on the Ethereum blockchain. The idea being that today, if you want to start a fund and run it as a business, the costs are very high, and that requires a certain level of assets under management, which can be quite a hurdle if you have talent, but you don't have those assets. That business is basically out of reach for you. And this is because there are a lot of costs that are involved in the management of a fund. So you have a legal requirement to enter into an agreement with an administrator, a shareholder registry, valuation agent, transfer agent, custodian, legal, regulatory. All these things have immense costs when all the person really wants to do is discretionary management of funds in a portfolio. So the idea was, how can we reduce those costs to make more funds and more fund managers a viable business? And so the idea was to take all those things which normally are contracted out to third parties and put that all inside of code running in a smart contract on the blockchain. The reason we want to do that is because there's a certain transparency to it, there's a certain immutability to it, and the costs are worlds different. So, okay, so Melonport was, like I said, a 2-year project. We finished our project at the end of February of this year. and put the first version of the protocol live on the Ethereum blockchain at that same time, or right around the beginning of March. And what a protocol actually is just a series of smart contracts, and these smart contracts interact with each other. We, on top of that, built a kind of a middle layer built in TypeScript, and then a interface layer that people can download and use to manage a fund. And of course, the interface makes it easy to interact with smart contracts. But again, the core and important piece that we created were the smart contracts. And if I had to summarize how it actually works and why it's important, think of it this way. We have in the current fund environment, there are lots of counterparties involved because there's lots of money involved. And what has happened is we have this network of trust where each counterparty is kind of keeping their eyes on every other counterparty. And sorry. Let's see, where was I? Each counterparty, we have this web of trust, and if I had to summarize what the Melonport protocol does, is it allows a manager, a fund manager, discretionary ability to make changes to a portfolio, to buy and sell assets, but they can't steal the assets, right? So that's kind of the breakthrough with these smart contracts. You can have discretionary movement of funds, but you can't steal it. That's the security involved. And we think that's a real breakthrough because we believe very strongly that over a certain period of time, very short 5-10 year time frame, all assets that we know today, whether it's equities or bonds, fixed income instruments, derivatives, all sorts of things will eventually be tokenized because the benefits are so great, right? The settlement times are very low, the security is very high, the costs are very low. These are all important innovations in the space. My colleague Hans-Jörg Hennig is here tonight also from the MAMA Association, that's the Multi-Chain Asset Managers Association. And we just came from a classroom at the University of Liechtenstein where we split a group of students into 4 teams. And each team is going to run a portfolio, and it's going to be like a contest over 4 or 5 weeks or so. And MAMA sponsored this event by providing some Ethereum for them to create the portfolios, to pay for the gas. But then once the portfolios are set up, they will invest in the portfolios, and these will be then run by the teams of students. And so we just got done with that exercise just up the hill here. And this is an example of one that we just created. So this is the front-end interface that you see. Of course, you don't see the smart contracts here, and that's kind of abstracted away from the user on purpose. Here, this is a fund called UniFL Fund 2. Now, what you'll see is an asset universe that they can invest in, and right now, these are just simple ERC20 tokens on the Ethereum network. Like I said, eventually, we foresee all kinds of assets being within this universe. But for now, that's where we are. And the manager of this fund has the ability to trade in and out of these assets through 4 different decentralized exchanges. At the moment, you can see that the AUM of this fund is 0 because it hasn't been funded yet by MAMA. But that's something that will change in the next few hours or perhaps tomorrow morning. And then after that point, the students are then freely able to make trades and try to create performance for the investor. The investor can at any point redeem those assets, so he doesn't have to wait 3 months or 1 month or however long for a redemption window or a notice period or any of that. At any point, he can take those assets out. The investment manager, as I said before, has full discretionary power to change the asset allocation of his portfolio based on the market and the different assets available. Let's see. At the end of this competition, the students will be able to keep the management fee and performance fee that they've earned because of the time that they spent managing it and any performance they might have gotten from that. So that's kind of their incentive to do this. It's also a classroom exercise, so they'll be graded on it. But we hope it's a fun exercise, and it's really one of the first things of its kind. When the competition is over, the fund manager can shut down the fund, and all the assets automatically go out to the respective owner. That's the mama investor at that point. Right, so what we have is a fund that anybody can invest in, anybody can redeem at any point, and with total transparency. So when we created this fund, what happened is a series of smart contract calls to create new smart contracts. And like I said, a protocol is nothing more than a collection of smart contracts that kind of interact with each other. So in the Melonport platform, we have many different smart contracts that serve different purposes. So for example, we have a smart contract called accounting. Right? So when we create the fund, we have an individual smart contract, which is kind of the core of the fund. It's called the hub. And then as the fund is created, we plug in these new smart contracts, which kind of are the analog to the counterparties that we know today. So for example, we have an accounting smart contract that kind of fulfills the functionality of an administrator. We have a shares smart contract, which fulfills the role of a shareholder accounting. We have a vault, which kind of fulfills the role of custodian, and so on. And what you see here is as these students created this fund, new smart contracts were created, each kind of according to this role. And as you can see, this was just an hour ago or so where this all happened. And the result of all of that is then basically the empty shell of a fund ready for investment from investors. So that's what we have right now. I think if anybody has any questions, yeah?
If I do a redemption of my part of the fund,
Yes.
Can I make Ethereum? Do you sell it pro rata, or do I get all the assets which are in there percentually?
Yes, that's a very good question. So there were a number of design considerations that we thought long and hard about this. So if you, first of all, when you create the fund, you can specify which assets you want as subscription assets. So that means which currencies or tokens can I use to invest into the fund, right? You can choose one, which is Ether, or the whole universe, however you like. When someone redeems, it's basically an in-kind redemption. So they get a perfect pro rata slice of all the assets. So this solves a couple of problems. So one is, if we were to redeem in the subscription currency, we might have to sell, right, to fulfill that redemption. And even if we didn't have to sell, it would still throw off the allocation, and the manager would have to come in and manage that. So that's one. And the other thing is that today, what happens in the fund world is very often an asset becomes illiquid, right? And then what do you do? Because you have to think long and hard about shareholder fairness, right? So what happens is they create things called side pockets, which are a real nightmare. And you kind of segregate out those assets and keep it separate from new investors that might be investing. This kind of obviates that whole problem, because if you're redeeming a kind, then it's up to you to liquidate when and how you want, and at what price you want. So that solves that problem. So the answer is, it's an in-kind redemption.
On the other hand, it's a nightmare for the investor because he gets 100 assets and has to sell them.
Potentially. I mean, we don't have 100 yet.
Yeah, but
And personally, I kind of foresee services that might resolve that, right? So they may take the assets and then convert it for you, right? that's a possibility. But right now, again, this is a version 1. We've kept it simple. We stayed with the basics and tried to solve a specific problem.
Very interesting to me is being kind of the new expat in Austria is dealing with my American retirement funds, my American 401ks and all that kind of stuff, and make it really difficult to sort of keep the same level of control you can keep when you're a resident of the United States. Is that a market you see this playing into, being able to manage retirement funds and stuff too?
Well, I think that really depends on how the laws evolve in the different jurisdictions. I mean, what we see that we can do with the technology is a completely different story and completely independent of how each jurisdiction is going to form their laws. And we're very hopeful for Liechtenstein, right? Because I think it represents a real opportunity for the country to be a front runner, to really make those courageous changes first, and then reap the benefits.
Nobody can afford to retire.
I mean, like I said, our vision and our conviction was really that we see the space drastically changing in the time frame of 5 to 10 years. The benefits are too great for this to be ignored. So that's.
Now that Melonport RP no longer exists, has anything changed how you collaborate and also how you get paid as an employee? Or
Yeah, I'm not an employee anymore. The company was dissolved, and the idea was kind of a bold idea from the outset to really create a decentralized platform, a decentralized protocol in all respects. And so we're striving for that direction. I think you kind of have to see it as money was raised so that we can create this child and get it kind of walking on its own 2 feet, right? So that it can slowly become a strong protocol on its own. And so what we've created now is what's called the Melon Council. It's not decentralized in the sense of having thousands of nodes or members, right? Right now there are 12 representatives, I think, and they will be in charge of making decisions about how the protocol evolves. So how it's maintained, how defects are fixed, how new features are added, and even if new players in this Melon decentralized finance ecosystem can get funded. So that's the whole. That's the goal.
So they will decide if a developer gets some reward for his work and stuff.
That's correct. That's right. So they would submit a proposal. Anybody is free and open to submit proposals. They can be. We're trying to create a broader ecosystem or more interesting, richer functionality. Submit the proposal. It's discussed and funded if it seems if this party has the capabilities and it's a good idea. The goal really is to expand the ecosystem to become more functional, more of a solid solution for real life asset management. Yes?
Is it an open source project?
Absolutely, yes. I think in the crypto space, if you're not going to survive very long if you're not open source project. I think that's a must.
How do you deal with KYC error?
We don't. So what this means is, like I said before, technically we can achieve a lot. We can do a lot of things. We can really replace this kind of trusted network that is formed around asset management today. So that's the technical side. If I create a fund and I start accepting money from people all over the world that I don't know, I'm probably in a little bit of trouble. So the fact that we can do this technically doesn't mean that we've solved it yet on the legal side. And that's now really the big role for Hans-Jörg's organization, MAMA, to help inform the different regulators, the different jurisdictions, lawmakers, how this technology can look going forward, why it's also beneficial for them, right? So that we can get these laws changed And so this protocol is kind of legally agnostic, right? It will just do it. It doesn't have this idea of this is legal or not. But we've built in certain ways to make it easy. So for example, we have on the risk management and compliance side, we have smart contracts that you can configure. For example, very, very simple one is a whitelisting for investor addresses. So anybody that would successfully invest in the fund is on that whitelist. And you could even take that even further and say, well, let's put that whitelist contract in control. Let's put the regulator in control of that. So they're the ones that are doing all the KYC, AML, and ensuring, yes, this person, this entity, via this address can invest in this fund. So,
okay.
Yes?
What's your business model?
There is no more business, so there is no more business model. Underneath the Melon protocol, right? So, like I said, none of us are employed by Melonport AG. Melonport never made revenue, right? Underneath this fund creation mechanism, right? If you're going to see all these different smart contracts that were created, you're going to see very tiny amounts of ether that were transferred with each one. So this ether is transferred into another special smart contract, which is like a mini exchange. And its job is to collect ether, and it will sell that ether to funds in this ecosystem in exchange for Melon, and it will pay a premium for that Melon. And it takes those Melon tokens and burns them. So the idea is that over time, with usage, the supply of Melon tokens becomes less and less. So that's an indirect answer to the business model question.
Okay, then let's go to the next speaker, the last one for today. This is Edward from Polkadot. Let's give him a bit time to set himself up. He's just arrived from the university. Okay, then it's your stage, Edward. Polkadot is a project created or founded by Gavin Wood. He's very well known for parity as well. Okay.
Thank you. I'm Edward Thomson from the Web3 Foundation, and I'm very happy to be back here in Liechtenstein again. I've been here a couple of times before, and I want to thank Klaus for letting me be here on stage, to Demelza for the original invite, and Roger for, the usual. So, this here is a cool graphic. It's not really our logo. Everyone thinks it's our logo. It's actually just a cool picture or a cool video. This is my details. I'm happy to have questions via email, or if you want to send me something on Twitter, also pretty happy with that. I have this at the end of the slide, at the end of the presentation, if you want to take a picture either now or at the end, it doesn't matter. There'll be ways to get in touch. So, I don't know how many of you actually know about the Web3 Foundation. We are headquartered in Zug, so we are a Swiss foundation. We collected some money in 2017 in a token sale, which most of you would call an ICO. This was about 50% of the tokens for a project called Polkadot, mainly for Polkadot, but our vision at Web3 Foundation is this idea of a decentralized web, or decentralized internet. So, I don't know how much you guys already know about this. I'm not sure if it's like Blockchain 101 is your level. I'm going to try and take it fairly gently. I don't want to assume too much knowledge beforehand, so I'll try to just step everyone through. I'll say something only very briefly about Web3. I will focus mainly on Polkadot. Web3 is the idea that if Web 1 was about retrieving data from the web, and Web 2 was about putting data onto the internet or the web, Then Web 3 is about owning your data. You hold all of your data locally. You can hold it locally. Rather, you have the option if you want to hold it locally. You own your private keys. All the encryption will be done on your own side, and you might use blockchains for things like trust, for identity, for payments. Use blockchain where it makes sense to use it, and then use another solution when it makes sense not to use blockchain. So blockchains are good for many things, but maybe not for everything. And the idea of Web3 is to be decentralized as much as possible, while accepting that some things will always be centralized. So, we are Swiss Foundation. Gavin Wood is our president. He was a co-founder of Ethereum. You've probably been to CoinMarketCap. You've probably seen that Ethereum is #2 market cap with $15–16 billion of value. And this was the guy who was part of the founding team. He was part of the Ethereum Foundation, and he was the CTO and actually wrote the first proof of concept, and maybe even a lot of the second proof of concept for Ethereum. And that's maybe some of the reason that I was personally convinced that whatever he will build next, which is Polkadot, should hopefully be good. I'm not saying anything about price, I'm not saying anyone should buy the tokens, I'm just saying technology-wise, it's probably going to be pretty interesting. He was also the one who coined this term Web3. If you go into Google and you search for the term Web3, you'll find some old texts from like maybe 20 years ago about the semantic web. It doesn't really matter what that means, it's just someone decided Web3 could be something a long time ago. But that definition never really stuck. The popular definition of Web3 right now is this one where you own your own data, where you have your own private keys. And this is basically the definition that Gavin proposed back in 2014 in a blog, where he's talking about dApps, which is decentralized applications. So we kind of take that as like the birthplace of the current wave of Web3, and so it's kind of fitting that we, with Gavin as our president, we are the Web3 Foundation to try and make this happen. So that's kind of just a very brief introduction to Web3 Foundation, just to kind of set the scene. I work for the Web3 Foundation, I don't work for Polkadot. Polkadot is just protocol. We have Gavin, who is also a co-founder of Parity Technologies. Parity Technologies is in Berlin, and they're famous for producing the Ethereum client called Parity. And now they're working on Polkadot. This is like their next step. There's a little subtlety in there that they're actually working on something called Substrate. Substrate is this generic blockchain framework for you to build any blockchain. And it just so happens that with this Substrate framework, you can actually build Polkadot with that framework. But I'll try to make that clearer throughout the presentation. So this is the contents. It's just text. I'm sorry. It's not particularly interesting, so I'm going to skip it. This is Polkadot in a single sentence. If you understand this from a single sentence, you've got it, and you can go home. So what's the idea? So the idea is that you have a multi-chain platform. It's not just a single blockchain, but many blockchains connected together. So that's the multi-chain part. If you're familiar with Ethereum, if you're familiar with Ethereum 2.0, Ethereum 2.0 is some future where Ethereum is not just one single Ethereum chain, but up to 1,000 potential shards. Each of these shards are the same, so if you put a smart contract onto one of the shards, it's basically as good as putting the smart contract to any of the shards. And you might say, why do you want to have this sharding solution? And the answer is pretty simple, it's about scalability. We have one single Ethereum blockchain right now. If we had 1,000 of them, then there's a lot more that we can do. There's more transactions that we can have. We can have more smart contracts in parallel at the same time. And Polkadot, when it was born in Gavin's head, it was actually meant to be a solution for Ethereum. It was a sharding solution for Ethereum. What has changed, at least initially, was not to make every shard is the same, but to make every shard different, should you choose to. And this is the heterogeneous. Heterogeneous just means different. So rather than everyone being the same, they can all be different. And this is something that will become clearer as we go through the presentation. So, this is Blockchain 101. I mean, is everyone here familiar with blockchain? You've already been to these meetups before, right? You've got a pretty good idea. So I can be really brief. The idea is that you're here on your laptop, you're in Liechtenstein, you're trying to buy coffee at Starbucks with Bitcoin, or you're trying to buy drugs on the dark web, not really, and you want to set the transaction. So where do you push your transaction to? You have to push your transaction to a mining pool. The mining pool collects all the transactions. That's these guys. They are the mining pools, they collect the transactions. And as you know from Bitcoin, there is proof of work, and there are miners. So the miners have to do the calculation to essentially seal the blocks, which proves that they're valid. And you can see a miner in Iceland, in Russia, and in China. That's these guys. So this is part you're all familiar with. Let me draw this in a different way. These are you guys on your laptop, you're here in Liechtenstein, you're trying to buy coffee at Starbucks, which doesn't even exist in Liechtenstein, but hey ho, let's pretend that it does. You make some transactions with Bitcoin, you push it out to the mining pools. This is all done automatic. You don't even have to think about this. The software on your laptop does it for you. And then the block proposals, so after collecting in all the transactions at the same time, they have a block proposal. This is a block, which then goes to the miner. The miner does the calculation, says, yep, this block is valid, these transactions can happen, no one is trying to cheat, and it pushes it back to the rest of the network. So this part you probably already know. This is really Blockchain 101. And now I'm going to say, okay, here is Polkadot. It is conceptually very similar, despite being a lot more complicated. So again, here you are in Liechtenstein. You are about to push out your Melon fund. You have this automated fund that you want to push out because everyone does finance or legal here, obviously, right? And you have this great idea for a portfolio. You're going to own everyone with your great portfolio that you have constructed in your mind, and you're going to collect your 2 and 20. But in order for you to do that, you have to push out your fund. Somehow you have to create the fund. You may have your own Melon chain, which is another thing. I'll get to that soon. So we have these collators. The collators in Polkadot are like the mining pools. They collect the transactions, they collate. It's pretty simple. Then we have the validators. And the validators have a very specific function, which is to validate the blocks. They're like the miners. So whenever people are pushing out transactions on their laptop, they push it to the collators, who collate the transactions, who are the mining pools, essentially. Then with the block proposals get pushed to the validators. And the validators say, yeah, this block is valid. This block does not contain any double spending. You don't want malicious transactions, of course. And of course, you can prove this all cryptographically. So this is kind of Polkadot in a 101 kind of sense. Now, this is me drawing it in the other way. This is me saying, okay, instead of being mining pools, you have collators, and rather than being miners, again, it's validators. With the different colors here, I'm basically saying each collator can be different. So each of your mining pools can have different logic, different business logic. So the one at the bottom right may be for smart contracts, or maybe it is going to be gaming. So you have a gaming parachain, which is specific only to gaming, nothing else. And maybe one is for gambling. So the chain is only for gambling and nothing else, or for asset management. And the idea of these chains being specific to the business logic is that they're much simpler, one, to do security reviews of, and they should be more efficient, and they're much more customizable. So you can customize it specifically for what you want to do. And if you know Ethereum, you know that there's gas costs, but with one of these chains, there doesn't need to be gas costs. I'm not saying that that's necessarily sensible. You still have to think about anti-spam or a mechanism for anti-spam, but in principle, you could remove gas costs entirely. And yes, there is some investment in terms of time to actually build a parachain. It may be worth your while, and hopefully I can convince you by the end. One more thing. So each of the collators can be different. Essentially, the collators, it's like a pool of collators. It's not just one machine. It could be 5, 10, 100, whatever. But each of the collators, despite being different, they all share the same validator set. There is one single validator set, which is in the middle, and there's this notion of shared security, which I actually have in a later slide. So, again, Blockchain 101, transactions, hashing, you build a block proposal, miners, etc. This is a rather naive, simplistic idea of Polkadot, rather than being the network architecture, which I showed you in the previous diagram. This is like the data architecture, if you want to call it that way, or the data perspective, whatever. So parachains is what the paras are. This is a parallel chain. Each of them can be different. Each of them can be bespoke to your business logic. There is the relay chain, which is the one that the validators maintain. So the chains, which are parachains, can be as complicated as you want, but the one which is the relay chain is actually as simple as possible. And all it does is collect proofs. Okay, what do these proofs look like? The proofs are that each block transition, so each time you jump from one block to the next, you provide a proof that the transition was valid, which is pretty sensible, right? So the proof goes to the central chain and is kept there, such that people can see that whatever you did in your chain, specific to your chain, is a valid transition. Therefore, we know that you haven't cheated on your specific chain, which means that another chain from someone else, if this side of the room was doing a gambling chain, they have to be able to trust the other side who's doing a gaming chain. And so if your blockchain submits a proof that everything is valid, it means already that the other chains can trust you. Which means that you have essentially, when I say trust, cryptographic, it's trustless. Now, the extra kind of interesting part is that each of the parachains are built using a framework called Substrate. This is the one I mentioned, which Parity are working on. And each of the parachains here at the top, they're essentially, you imagine they've been built with Substrate. So they're built specifically with this software. And those are the ones which are native to Polkadot, which is why Polkadot is a platform rather than a single blockchain. And the idea is that that's great, which it is, but you can also connect an outside blockchain, like Ethereum or Bitcoin or whatever you want. It is possible to build bridges between the outside chains and Polkadot, and we think that that's going to be attractive. So this is almost everything that I said in a single slide. This was a slide that Gavin showed in 2017 in June, whenever he visited London. And this was the first time I heard the project back then. I was sitting in the audience, a bit like you are now, and I thought, holy, that is an interesting slide. I didn't understand it. I think I understand it now. It's complicated, and I don't think anyone has done an ELI 5. ELI 5, I'm going to explain it like I'm 5. I don't think anyone's actually taken this diagram and made it simple. We have a wiki where we try to explain everything as best as we can, but there's a lot to it. So, everything I said about colliders and validators is here. I'm actually not going to explain this diagram right now, but we'll try and take it through step by step. If anyone wants a picture, I can leave it for another 10 seconds or so, or we're good. You want it? Go for it, sorry. We have plenty of time. I hope. No worries. Oh, okay, so part of the reason that we want to build Polkadot, or why anyone would want to see Polkadot exist, is that while blockchains are great and people have made lots of money scamming people, there are some technological problems, and also scams are not so good. But anyhow, on the technological problems, this is kind of like an overview. Many of them you probably already know. It's a text slide, it's a bit boring. So what I'm going to do is I'm going to explain everything here, rather than sit. So really, really super simple. This is kind of meant to be as simple as I can make it. Hopefully it's a bit more interesting to see diagrams than it is to see text. So the left-hand side is blockchains that we have now. So something like Bitcoin or Ethereum, if you want to run a full node, you have to store all of the data. Which makes sense, there are good reasons for doing that. But in a world where you have many, many blockchains, it's not really feasible to store all of the data for every blockchain. And with sharding, when Ethereum 2.0 comes, and when Polkadot comes, we are on the right side, where we basically accept that not everyone will be able to hold all of the data for the entire network. It doesn't really scale. But we still want it to be such that it's safe to transact. When I say transact, I just mean send data from one to the other in a trustful way. So that's part of the solution, is to accept that you have to split the data into different shards. Here, it's about transactions per second. It's scalability, I guess, in a different way. So there's scalability of storage, and then there's scalability in terms of transaction time, or block time really in this case. So you're at Starbucks, again, you're probably in Switzerland since it's a Starbucks. You are at the train station, you're getting cold, you want a coffee, you want to pay with Bitcoin. I'm not including the Lightning Network. Let's ignore that for now. If we just take Bitcoin, you might want to wait for 6 confirmations. And if you wait for 6 confirmations to pay for your coffee at Starbucks, you're going to be waiting for an hour, which is not ideal. So what we're saying is that we can actually make the block time a lot smaller, which, you know, there are concerns, there are challenges. It's not necessarily easy, but it is possible. And at the same time, rather than put every single transaction onto one single chain, we can put it onto multiple chains. Moreover, there are some transactions which don't necessarily need to be on the same chain. If there's a gambling chain, why does it need to be on the same chain as a gaming chain? Or on a weather data chain or something else? It doesn't make much sense for them all necessarily to share the same chain. And here's probably the big one that people kind of know Polkadot for, is this idea of interoperability. So the left-hand side is what we have now, where we have each of these chains in isolation. So we have Ethereum, or something like Ethereum. It's a smart contract platform. It's very useful. We have something which can be a banking chain, so it's a private chain where most of the data is kept private, maybe with ZK snarks. At the bottom we have Zcash, which uses ZK snarks. And then on the right we have an Oracle chain. So you might know of the Oracle problem, or of Oracle chains. The idea being that you have some source of truth in the world, and you may want to trust them. But you know, if you go to Bloomberg right now, you don't take Bloomberg over a blockchain. You go straight to Bloomberg, and there's a connection, peer-to-peer, or with the provider, even service provider. Sorry. But in the future, there might be something really interesting that you want to do with your Melon fund, such as have automated trading, and you want to take a price feed from Bloomberg, but then you might not trust Bloomberg. You might want, say, 5 different data sources. So you want to have Bloomberg plus Morningstar or Reuters or whoever they use in asset management. Take a kind of combination of the prices for which you want to set, for which you want to take in, you know, your as like indicators or for triggers for buying and selling something. And so this is the idea of an Oracle chain. Now the thing here in the old days, when I say the old days, this is now, we have all of these great blockchains, but they exist in isolation. And while it's great that you can put data onto an Oracle chain, if it's just by itself on a single chain, isolated, it's not really that useful. You can't really use it. You want to actually be able to get the data out of it, but you also want to be able to trust the data whenever it crosses from one chain to another. The right-hand side is it's just a diagram of saying we want Polkadot to be this kind of, I don't want to say central, because central is a bad word in this industry. It's a chain that sits there in the middle, but it's not central. Yeah, I can't think of a good word. But anyway, the idea is that you can bridge each of these different networks, and each of the data can flow from one network to the other, and ideally in a trustless way. And when it's trustless, it's good because then you can automate it, such that you can have your Melon fund doing automated trading from price feeds that is taken from an Oracle chain. And at the moment, I think you probably could do it, it'd just be a bit kind of hacky. It wouldn't be so decentralized. This kind of gives you some idea of how Polkadot might be useful in this future, this Web3 that we're talking about. Speed, this is kind of one for programmers, which I'm guessing most people are kind of legal and finance here. Is there anyone who's a programmer? Yeah. Cool, well, 3, 4. So, if you've ever dealt with the EVM, which is Ethereum, so this is the state machine or the virtual machine of Ethereum, you know that each of the numbers inside of this virtual machine are 256 bits, which, if you want to add two numbers together, so 256 bits, it's not necessarily optimized for your computer architecture. What it's more likely to be is that you've got a 64-bit computer, like most people, or it can be 32 as well. So by using WASM, we have a different type of sandbox, which is highly generic, and you can define your blockchain logic inside this WASM sandbox. And it's actually going to be faster. Maybe not hugely so, but enough such that it's just more efficient. So you don't have to use these huge numbers, which people are never going to use a huge number. 256 bits is a huge number, and people are just never going to use it. I mean, it's so big you can't even comprehend how big it is. 256 bits is 2 to the 256. That's how big the number is, and that's more than there are atoms in the entire universe, I think. So there is no way you're going to have two numbers that size you want to add together. Most of the numbers are just going to be 0 and then like 0, 0, 0, 1. So you want to add two numbers together. It's just really inefficient to carry all of these extra numbers around. And so, of course, there is a better way. You can use something which is actually more fitting for your computer architecture. So there's this idea of speed as well. This is not necessarily specific just to Polkadot, but it's just one of the things that we've realized is, hey, this is a problem with the old style of software. We can do something about that. I touched on this before. So isolated security versus shared security. The validators in Polkadot are central in the sense that they're logically central, but we can have 1,000 validators. So validators, as I said, are kind of like the miners. They check that the blocks from every parachain are valid. So it doesn't matter what your parachain is, whether it's gambling or whether it's gaming or whether it's asset management or whether it's something else. You have a transition from one block to the next, and you have to give a proof of the transition. You have to prove that the transition from one block to the next is valid. And the way that you do that, the way that you get it signed off and accepted by the whole network is that you submit it to the validators. And the validators give you proof, which hopefully you remember from an earlier slide. Now, what does this mean here? So the left-hand side is this traditional isolated security. So someone out here wants to start a new chain. Someone has decided that they want beer chain or whatever. And someone in the audience says, hey, I've got this beer chain, who wants to become a miner on my network? And you might say, well, I've got 10 friends who are sitting here who want to become miners. And you're very popular, and you say, actually, I actually know 100 people. I have them all connected to me on Facebook. And so you ask them to become miners. But you also have to incentivize them. So you have to pay them some sort of reward for mining on your network. But what we actually find is that most people don't bother. Most of your friends probably won't want to run miners. It's a bit of a pain in the ass. They have to update all of their mining equipment every so often. Not really good to do. So what else could you do? You could go to Bitcoin Talk. Obviously, that's where everyone went. You go to Bitcoin Talk and say, hey, I have this new blockchain, BBQ coin or beer coin or whatever. Who wants to come and mine from my chain? And people might say, yeah, I'll do that. But each time that they join your network and become a miner for your chain, they very likely had to leave a previous chain. They stopped being a miner in a previous network. So when Bitcoin Cash came along, arguably, there was a whole bunch of miners who left Bitcoin to then go mine Bitcoin Cash. And it kind of cannibalizes the source of miners. Sure, new miners will come in, but it's not really ideal. And what we have on the right-hand side is rather than you finding new miners, rather than you finding 100 friends that you have on Facebook, what if there was already a source of miners that already existed, who are already in the network? These are the validator nodes who are already there. So the validators provide a service to the whole platform, which means you don't have to be that popular. You can just code away in your mother's basement and build this great blockchain that everyone wants to use without having any friends, because you can actually buy friends. You can pay for the service, you can pay for the validation. And that way you don't actually have to cannibalize the miners who already exist. You don't have to pull them away from a different chain, because they provide security for your chain.
Sorry, I had to test the meal.
No worries. Hopefully you didn't die, or won't die. So they provide security for your chain and everyone else's chain at the same time, which means that you don't have to find new miners. And this is something which is unique to Polkadot. There's only one other team who's thinking about this, but they actually haven't started yet, and that's Cosmos, who you've probably also heard of, who are also doing something really similar to Polkadot, and it's also pretty cool. So, privacy, left-hand side is what we have now, where Bitcoin's privacy is not ideal. If you have tainted Bitcoins, you won't be able to take them to exchanges. You go to Coinbase or Kraken with tainted Bitcoins, they won't let you exchange them for fiat. It's just not possible. Now, I'm not saying you should necessarily do anything dodgy. I'm not saying you should go and trade drugs on the dark web and then try to move, Z coins onto Coinbase and cash out to fiat. That's not really what I'm saying. I know I'm kind of going in that direction, but it's not really the point. The point is that Bitcoin, as great as it is, privacy is not so good. And it's the same with Ethereum, and it's the same with many other chains. So it's not unique to these two. So we can do things like Zcash, we can do all these great funky Z-based marks to try and hide transactions, which is nice, but it's also just transaction. What if you want to have smart contracts? What if you want to, God forbid, put medical data onto a blockchain? As daft as I think that is, people may want to do it, and I would rather they do it in a privacy-preserving way, one which is mostly anonymous. And now you have this kind of conundrum where you want to keep data private, but you still want to be able to share your blocks with a validator set. So you need to find a cryptographic way to keep all of your transactions and keep all of your data private on your chain, your parachain, but still provide a cryptographic proof that the transition from one block to the next is valid. And that is possible. It's possible right now. You might know of a project called Enigma. It's on Ethereum. So the Enigma project is trying to do something pretty cool where you can have the sending of private data without revealing it, but still make it valid. So this is something which will be possible. It's not something that you have to do in Polkadot. If you create a blockchain on Polkadot, you don't have to do this. You have the option. So, developability. This is a bit of a mouthful. The idea is, it's kind of a joke that on the left-hand side, if you want to create a new blockchain, you would fork the Bitcoin code because it's the lazy way. You know that the code works, and it's great. That's where everyone starts. Everyone starts at Bitcoin. But it wasn't really designed for you to really modify it. It was designed just to do what it was designed to do, send transactions. So what you would do is you would clone the software, you would clone Bitcoin, you would go to Bitcoin Talk and say, hey, I've just created BBQ coin. Who wants to join? Who wants to be a miner? I'll give you lots of BBQ tokens. What we're saying is, that's nice, but it's not really so easy to develop with. It's not really so easy to customize. On the right-hand side, it's also not a great diagram. I have to be honest, this was my best skills in Microsoft Paint. It kind of sucks, I know, I get it. You don't have to be so harsh. This we're calling a Polkadot runtime environment. Maybe again not so descriptive, but the idea is that you have something which is common to every chain. This should actually be called a networking layer. It's a libp2p library, but it's networking. And so networking is where you have peer discovery, which, like you have in Bitcoin and Ethereum, when you spin up a new node, you've just downloaded the software on your computer, and you want to find peers in the network. That's what networking does. You also want to find, or you also want to come to consensus. You want to be able to agree upon what the longest chain is. And so there's a consensus layer. There's some logic to do that. And this is pretty common across any blockchain. We're saying, what if we gave you a software framework where all of this was already done for you? And all you had to do was pick configuration options. You just had to choose, did you want POW, proof of work, or did you want proof of stake, or proof of authority, or proof of something else crazy that you want to code yourself? And so the idea is that you take this modular framework, which is highly customizable, and you can do your own thing. The WASM sandbox, for the coders, that'll mean something. If you're not a coder, don't worry. It's, yeah, don't worry about it. Runtime. So the runtime is the good part. That is where all of the magic is. That's the interesting part where your business logic goes. This is where Melonport would put the logic of their funds, the fund, how to manage them, how to create a fund, how to manage risk. That would all sit in the runtime. Or if you're used to Bitcoin, they have a UTXO model, which is the way that they track unspent coins. The logic of the UTXO logic would sit inside the runtime. Or if you want to build it like Ethereum, where you have accounts and balances, where you have an account, and a bounce, which is much simpler. I'm not saying which is right or wrong, it's just a different way to look at it. All of that kind of logic, the code, sits inside the runtime. So this is kind of our way of looking at blockchains as layers. And there's some common layers, and then there's like a top layer, which is where it's customizable. And to cut a long story short, developability is about making this as easy as possible for you to develop a blockchain. I'm not saying you should, but you could. So, governance. This is a highly debated topic. There are many Twitter fights about governance. If you go to Reddit, there's just as many fights on Reddit as there is on Twitter. And the point being is that governance is messy. It's always been messy. I think it's always been messy throughout human history. And how do you have governance in a decentralized system? And Ethereum and Bitcoin have one way. I'm not saying it's right or wrong, but we're taking the view that maybe we could do it in a different way. So on the right side, we have this is an unfinished model. This was an image from last year from a presentation that Gavin did, where each person within the network who holds tokens will have some ability to vote. But it's not just the fact that you have ability to vote and signal what you intend to do, the result is binding. So if you have, let's just make one up, you submit a public proposal to give 1 million tokens to your friend. So you basically code that, put it into a piece of code to say, this address will receive 10 million tokens. You will say that your proposal will be open for voting within 1,000 blocks time. And once the proposal is open, it will remain open for another 1,000 blocks. And within that time, at the very, very end, there will be a conclusion, and the conclusion, yes or no, will be enforceable. And if everyone votes yes to give your friend 1 million tokens, then the network will enforce that. So the idea is that it's binding, that it's on-chain. I'm not saying that's necessarily right for every blockchain. I think if you were to try and push this onto Bitcoin, it wouldn't work. It wouldn't work very much in the social sense because people don't want it. But that's fine. And it's kind of the same of Ethereum. That doesn't necessarily make it wrong to be messy, it's a choice. And what we're seeing is we have seen enough of this governance, this messy governance system, and we don't think that that's right for every blockchain. We're taking the opinion that we want it to be a bit more orderly, we want it to be enforceable, and that's why we're going for the right-hand side where it's a bit more structured, where the token holders, the people who actually have something at risk, are the ones who are voting yes and no. If someone proposes something kind of crazy, like to try and break the network, people who hold the tokens should be inspecting the code and saying, I'm not sure that's such a good idea, I'm going to vote no. So this is just a rundown of all the solutions. This is everything I just mentioned in text. Again, the text is not very good. If you want to take a picture, by all means. I'm not going to talk through it, I just did. Oh, did you want to take a picture? Sorry. And here, so at the Web3 Foundation, we are providing grants. If you're a coder, you can come to us for a grant. The project that you propose has to be relevant to what we're doing, so it has to be relevant to Substrate or Polkadot. But you have the chance to get $100,000 to build something, roughly over 3 months. There is some leniency there, it doesn't have to be perfectly 3 months. It doesn't have to be the maximum of $100,000, but rather it's up to. It's not an investment, we don't buy any equity, it's free money in the sense that we just give it to you. Of course you have to build something, and it has to be open source, so you have to provide it back to the ecosystem, but the money exists if you want to do it. And this is the website that you would go to if you're interested. So we actually have plenty of wallets, we have plenty of open source wallets. We now have an open source block explorer, we have an open source node explorer, and we're now getting teams to come in to build parachains. So these are just to give you some sort of idea of what we might fund, and if you have an idea, then by all means check it out, or if you're already working for a team, maybe there's some way that we can work together, maybe there's some way that we can bridge the network that you work for with what we do, which is what we're going to do. So if you want to learn more, Polkadot.network. Wiki.web3 is actually more about Web3 as an idea, and an idea of Web3 being viewed as a tech stack. It is technical. If you're not a technical person, it may not be that useful. It may be nice to see, to understand how do we view the different layers, how do we connect chains together. So Bitcoin and Ethereum are layer 1, and it's layer 1 of our tech stack. Something like Lightning is layer 2, so that it appears in layer 2 of our tech stack. And then you have various other libraries, various other projects who are within this overall idea of a tech stack. We basically try to show where these different projects fit, where they sit together. And it's quite a nice overview of this ecosystem of Web3. So I recommend checking it out. And as I promised, my contact information again, in case you didn't take it at the start, I'm generally pretty happy to take questions via email, generally pretty happy to speak to people over Twitter as well. And I could probably make this presentation available via email or via Class, whatever. So feel free to reach out. Or I guess, do we have time for questions? Or
Yeah, we have some time for questions.
so people are hungry probably. So
Yeah.
make sure it's good questions.
Give 3 or 4 minutes. I hope you heard that it was nice when I tasted the food. So sorry for that. Any questions? No?
Wow.
The food is good. Yes.
Oh, here we go.
What you do with the parachains and the proof chain, is that something comparable to this much simpler but proof concept that Veriblock is using to use the Bitcoin blockchain to prove or ensure altcoin blockchains? So by taking a hash of an external blockchain and writing that as a opt return command into the Bitcoin blockchain. Is that something comparable, and could you reflect?
Yeah, it does sound pretty comparable. So you're saying like there's a whole bunch of altcoins out there, so a whole bunch of chains which already exist. Maybe we could submit some sort of cryptographic proof to Bitcoin, some sort of proof which proves that maybe the transition from one block in some random altcoin. It sounds similar to how you describe it. I'll be honest, I'm not 100% sure. I've heard of this idea. I've seen it in some, like a Cointelegraph or Coindesk type of report, but I'll be honest, I'm not the expert. The only thing which makes me think that it's different is that in that sense it would be very passive. You're submitting a proof to an opcode of Bitcoin where Bitcoin just holds it. So it just stores it, it doesn't actually validate it. And then what we are doing in our chain is that the validators actually have to ensure that it's true, and they enforce that it's true. So if you submit a proof to the validator, you're saying, here's cryptographic evidence that my transition from one block to the next block is true. Do you agree? And if the validators say no, then the transition can't actually happen. And the system is designed to enforce that only valid transitions can happen. All others should be blocked. So to that extent, the validators who maintain the relay chain are like the ultimate arbiters of the overall system. So it sounds like it would be a little bit different in terms of like a passive versus active kind of. Yeah.
How do you ensure long-term maintenance of the project? Say you run out of cash and what's the income model there?
Yeah, so we sold 50% of our tokens in 2017, and there's 50% left, of course, of which 20% will be sold to the world, to various people. And then of the remaining 30%, something like 9% of which will be retained within the foundation as our funding pot for the remaining years. And then that kind of missing 20% we're hoping to use to incentivize ecosystem builders to build within our ecosystem. Hopefully a lot of people can get there before Genesis. So, there is an idea. Of course, it relies upon our token actually being valuable, or at least not being zero, so we can have some amount of funding. It does mean that the foundation can run out of funds, potentially. It does mean that therefore it may come to an end. There may be other options such as maybe another sort of token sale in the future for one of the parachains, perhaps. So I wouldn't say that we have solved that problem by any means, but I think there's options for us to have money to sustain, hopefully for many years.
Okay. Any more questions or to one of the other presenters? No. everyone is hungry, huh?
How many people are actually working on this project, and what are you doing about security given things that happen in the past?
All right, thanks. Gives me a tough question. So the foundation, we're about 30, give or take, of which half of the team are in Zug, which includes myself. I'm now living there. The foundation is like the marketing, the outreach, the education, the team that tries to build awareness of the project. That's what we do in the foundation. We have essentially a partnership with Parity Technologies, who's in Berlin, and Parity are the ones who are the main builders of Polkadot, or at least of the first implementation. We're actually funding 2 more implementations, so there's now 2 more teams. ChainSafe in Toronto and Soramitsu in Tokyo. So while Parity are building in Rust, Soramitsu are building in C++, and ChainSafe are building in Go. So this is kind of like where Ethereum has multiple clients, where we want the same kind of idea within Polkadot. So then you may say, okay, how many people is that? Parity are around about, I think they're between 80 and 90 people total, of which I think it's something like 60 plus are developers. And at some point, each of them probably touch upon Polkadot, but Parity also do a Bitcoin client, and they also do an Ethereum client. But I'm not sure the exact breakdown on the Zcash client. But I'm not sure what the exact breakdown is. I think most people, to some extent, will be doing something for Polkadot out of that sort of 60 plus developers. At least within Parity, and there's another bunch here in ChainSafe, which is like 20, so I'm not sure, I don't know what the number is. What was the other thing you said?
Just about security about audit.
Alright. LOL. Thanks. So that's obviously the elephant in the room, the tough question. Yeah, so after the badness of 2017, the 2 Parity wallet hacks, which everyone knows and does not love, Parity have really taken it upon themselves to improve their internal security processes. They hired a chief security officer to implement new processes within Parity, and at the same time they've also partnered with a team, they're in the US, what's it called now? Trail of Bits. Trail of Bits are a professional security firm. They've been around for a number of years doing traditional information security, including pen testing and consultancy. And they're also very active in the blockchain space, building open source tools, etc. So Parity have gone to them and said, hey, we need some help with our security processes, and we need to get some better tools such that we can try to catch security bugs in our code before we ever deploy it. And at the moment, we're actually going through an audit of the Polkadot code right now with, I actually don't know who the team is doing. I think it's maybe another team, but we're going through a code audit right now to ensure that we actually have secure code. Fingers crossed. Thanks.
Okay, any other questions to anyone? Okay then, let's go and see the